Hello and welcome to the examples for Chapter 17. You can find the file that I'm using right here on the right of the list of examples, located just above this video. And I've taken the liberty of already taking number one's data and placing it over here in the worksheet by just copying and pasting it so that I can use this to get started. There is no description of this data, so, this might be kind of boring because there's no context. Yay! All right, so to begin off, we're going to start with, hey, let's estimate the multiple linear regression equation for the following data. And then what is the predicted value of y when I have these particular values for x1 and x2? So if you were to write out the regression equation first, I'm going to do that in a different color, just so it's clear which part is the part that I am adding. Okay, so for us, that would be that y is equal to, oh crap, this is formatting weirdly. Y equals, I'm going to pause this and fix that. Okay, I think I finally fixed my correction problem here. Anyway, so y is equal to, and now I need my intercept, which is b0, so 63.4 plus whatever b1 is times your first variable, which was x1. Now, my b1 is 0, so instead I'm going to write minus 3.33, because that's my b1, times my x1 variable, plus my b2, which is positive 0.417. And then if I'm looking for a particular value, or a predicted value of y, I'm going to use this equation again that I just made, but I'm going to be plugging in particular values of the x's that I'm looking at. So since x1 is 9, I'll be putting in 9 for x1. Is there a reason why I didn't write x2 here? That's crazy pants time. Oh well, too late to fix it. And then 8 here, and then if you just go ahead and multiply and add and subtract those, you're good. You can come up with what your predicted value is, which I'm totally typing into a calculator right now, but it's 36.766 is what I got. So you should take a moment and make sure that you got the same thing that I did. Woohoo! So there's the predicted value for a particular x and y. And notice this is the first value that we have in our data sheet. So it's our first row, really. And if you look, the actual y is 35. So we're not that far off. We're a little bit overestimating, but not bad. Okay. The second thing they ask you to do is to find the predicted values for y. For pairs of x1 and x2 for all the values in the table. And this is actually pretty easy to do using Minitab. We've done this once before using a single variable. This will be our first time doing it with two variables. So we're going to go up here and I'm going to call this fits because that's what its name is in Minitab. And I'm going to go up and I'm going to hit the calc menu and go to calculator. And I'm going to tell this to store my values in fits. And then the expression I want to store is I want to do the line. So I want to do 63.4 minus 3.33 times x1 plus, what is it, 0.417. I'm typing these numbers in case you're seeing me not press the buttons. Times, and then I want x2. And this will produce the fits for me in that column. Let's go ahead and hit OK. And there are the values. Notice the first one matches what I got up here, so that confirms for us that we've got this in correctly. Yeah, so I should take this and put it in Word for my answers. There we go. And I'm just going to format this a little bit better. So watch me waste 5 minutes of video just because I'm anal about how things look. This is so pointless what I'm doing. Why do I do this? And I do it in every video lately. Woohoo! Oh, I feel sorry for you who listened to the whole thing. I'm mildly crazy. Anyway, the next thing it asks us to do is to find the residuals. So residuals, if you remember, is going to be your actual value minus your predicted. So I'm going to create a new one up here, which I'm going to call I'm going to create a new column, a variable, which I'm going to call residual. Rather expectedly. And then I'm going to go ahead and calculate my residuals again using the calculate menu. So I'm going to go up to calc, and then over to calculator, and I want to do, oh, I want to store this in residual, so I got to change my where I'm storing it into the correct column. And then residual, remember, is your actual value minus your predicted, which is what we called the fits in Minitab, and that's going to produce the correct column for me. And there's my column of information. So we should copy that and paste it over here. Okay, why am I doing this again? Oh, meticulousness is totally my thing. Okay, let's go. So the next thing we want to do is we want to calculate the residual of the standard deviation, which we also know as S. So I just need to find the standard deviation of these data. So I'm going to go up to Stat, Basic Statistics, Display Descriptive Statistics. Oh. And then I'm going to put in the residual because that's what I'm interested in. And I'm going to hit Statistics. And I'm going to remove all this junk that I don't want. Oh, I do want standard deviation. Whoopsie, almost like we got rid of the thing I actually needed. Woo! Alright, hit OK, and hit OK again. And there it is for us. It appears to be about 4.43. That seems a little inaccurate to me, but we're rounding a bunch, so that's probably a big factor with this. Oh my god, that's not how you calculate that. Shit. Okay, you could calculate S, the standard deviation of the residuals, by hand if you wanted to at this point. But I'm going to actually make Minitab do this for me just so I can get some calculations that I'm going to use in these later exercises. So we're going to go up to, sorry, a yawn going. Stat, regression. We're going to go to fit regression model because this is the more detailed output version. And we're going to put in y as our response, and then x1 and x2. Ooh, we're just totally the wrong thing for fun. For our continuous predictors, and I'm not going to mess with any of the settings for this. I'm just going to hit OK to get me some raw output. And if you scroll your output up, you'll see the value for S right here. And this is great if you have raw data. If you have raw residuals, you'll have to do it by hand. So I'm going to report the answer as being 5.17976. And again, you can do this by hand. I even have a video where we did this by hand. It was in, I think it was in chapter 4. Oh no, it was in chapter 15. Sorry, I'm misthinking about stuff. So yeah, there's that. Fun times. All right, moving on. Let's get it done and get it to problem number 2. Okay, so the first value we need to find is the SSE, which is the sum of squares error, which is actually the value that occurs right here. It's the one for the entire regression. So that's, oh no, wait, where is it? Oh, error, sum of squares error. Oh my gosh. I'm trying to do the one that's later. Oh no. Okay, so, I need to change this to purple. We know that the sum of squares error is the one coming off the error, and that is going to be found right here. So we use the adjusted sum of squares, so we're going to be using the 98.15 off of this. You can calculate this one by hand, but we are definitely not going to be doing that. So the sum of squares error can be found again right here. So the next thing we need to find is the sum of squares regression, the mean squares for regression, and the mean square error. And these are all located in this table, so I'm just making sure we know how to read this. So I know they gave us the sum of squares total, and there's a couple different ways you can use this to figure out what's going on. But we're going to use this instead, the output table. So SSR, mean square regression, and then mean square error. And we're going to need those to calculate the F statistic in the second part to this. And these are actually easy to find once you know what they mean. So their names are really designed to help you figure out what they are. So mean squared, let's do mean squared error. No, let's do SSR first. So this is the sum squares of regression, and that is adjusted right here. So sum of squares, SS, and regression, there the R is coming from, and that's the 685.19. Fun times. The next thing up is the mean square regression. So what you should do if you wanted to calculate this by hand is you would take the sum squared error right here, and then divide by the degrees of freedom for regression, which is the number that appears right here. So you just take this and divide it by 2. Notice that that shows up exactly right here. So yeah, you don't really have to calculate this one, you can just read it off the table. But in case you were wondering how to do this by hand, you would divide by the degrees of freedom of the model, which would be, for the entire regression, would be your number of data present minus your number of predictors minus 2. It's nk minus 2, in case you forgot. Okay, so on to MSE, or mean squared error. Yay! The mean squared error is calculated by taking the SSE, or sum of squares error, and dividing by its degrees of freedom, which is just your number of data minus 2. So that's how you do that by hand. You take that 98.15 and you would divide by n minus 2, which I have, how much data do I have here? I have 6. So you divide it by 4. If you do that, it comes out with, well, the adjusted mean square for error, which is right here, 32.72. So there's nothing really new going on. It's just a matter of reading the table. Okay. Next up, finding the F statistic. We calculate F by doing the mean square for regression divided by mean square error, MSR, divided by MSE, which from looking at our values above, we could do that as 342.59 divided by 32.72, which I calculated this earlier. I hate how it's writing fractions lately. So that's 10.47. Next up, I need to ask the question, is the significant overall? It gave us the p-value for the entire regression. It appears right here. Oh, sorry, I almost got ahead of myself. Look at the answer for C. Do you see it in the table? Oh my gosh, it's right there. Okay, so this is not that hard if you know how to read the table. Most of these things are already calculated. It's just a matter of picking them off and finding out where they are. Anyway, so is it, significant overall? Oh, I really wanted this to all fit on one page. Sorry. Remove enumeration, make it purple. Watching me do pointless things when it comes to editing is so fun, isn't it, guys? Woohoo! Feel free to leave some feedback below. Just, YouTube action. Anyway, so clearly, small p-value. It's close to 5%, so I can see where you might not reject, but I'm going to go ahead and reject this. So, yes, we reject the null hypothesis. I keep hitting R. At the 5% level. So this is like, since this doesn't have context, this is like reading stereo instructions. What does this mean? Remember the null hypothesis is that all your slopes are 0. So what you should be saying is at least one of these variables is significantly contributing to predicting y. Let's say predictors instead of xi. With a p-value of 0.044, because that's my p-value, which I'm picking up right here. So really, when you're looking at anything that has the word R in it, it's using regression. So you're going to be looking down this row. Okay, so that's testing the entire thing. Anything with error, you're going to be looking down this row. There's the stuff for error, the degrees of freedom for it, the adjusted sum of squares, and then the mean squares. So just, use the table to your advantage when you're calculating these. It really will help you understand where to pick up these values from. And it does make it significantly easier. Yep, there's no fixing that. Okay. All right, let's remove our action down to number 1. Or sorry, number 3. Oh, I'm doing so good today. You guys enjoying this? I have no idea. Feel free to use the comment section because no one does lately. Anyway, so we want to look at the meaning for b1 and b2, which are two slopes for our variables x1 and x2. This is going to be a little hard to do. I usually do this with stuff that has meaning like, oh, square footage and rooms, and then these values totally make sense. Oh wait, I'm on the wrong one. Analysis of variance. Where's my model summary? There we go. That's the one I need because I want to be looking at what these coefficients mean, what the slopes mean, B1, B2. So if I look at the first one, I'm going to say, for a given level of x2, be careful not to say that the other variables remaining constant, because that's a really common error with this, is if I know what's going on with that one, hey, each additional unit increase in x1 causes a decrease in y by, I should have just made up names for what these variables were doing, and then this would make sense. Anyway, and here's where I'm going to totally be cheap. I'm just going to copy this sucker and then paste it accordingly with what goes here. So now I'm holding x1 for a specific value and looking at what x2 does. Well, x2 slope is negative, or sorry, is positive. So I'm going to change decrease to increase. See? I'm hoping that you learn from me giggling at myself, making mistakes when I read things as like, hey, at least, I'm having a good time. Or here's how to laugh off when things go wrong. Life advice with statistics today. Okay, so that's how you'd interpret those too. So there's that. So remember increasing and decreasing. Slopes are ratios, so this is telling you how you should expect y to change as you change your x's by 1 unit. So slope, rise over run, and all that. All right. If you're having a hard time with that, go back to the chapter 4 video on how to deal with slope, and that will help you. Okay, so let's talk about B. Okay, so I need to find out the confidence interval. So I need to take the slope B1, which is located right here. I'm going to use the more exact version. I know I've been rounding it to like 0.333. I missed a 3 there. But I think I'm going to use the more exact version for this calculation. And then I need to add and subtract from it the t statistic times, careful, not t statistic, a t star value, so a t critical value right here. Times the standard error, which we have already in the table, and I've listed it up above. So the real thing that you have to do for work before you start, just calculating this, is you need to figure out what the t-stat is going to be. So since we're doing the regression, it's always the number of data that you have. So I have 6 minus the number of variables that we're using, minus 2 for the, oh no, that's the one for square error. This one we use just n minus 2. So I'm going to use 4. So we go up to graph. I'm using 4 because 6 minus 2 is 4. And I have 6 data pieces. Probability distribution plot, probability view. I'm going to go ahead and hit OK. And then I want the t. And my degrees of freedom is going to be 4. And I want shaded area. And I want the middle probability to be 95%. So I want 5% in both tails. This is just the quick way to do it. So it's like 5 here, 5 here. Well, 5 split in half on each of them. And hit OK. So the t I want is actually 2.776. Ooh. So let's see. I'm going to pull out my handy dandy handheld calculator and calculate both these. I'm going to pause you for a second. Okay, I'm back, and here are our values. For the lower end, I got negative 5.268. For the upper end, I got negative 1.209, and I'm rounding things. Okay, good enough. I'm using more decimal places here than there. That looks so awkward. Let's throw one more on here. There. Now I feel more comfortable. Okay, so that's our range of values for that one's slope. And then I can do the same thing for B2. So I'm going to cheat a little bit here and just copy and paste. I hate it when it does that. So then I want to use the slope for B2, which I'm going to have to roll up a little bit here to get it. Say B2, there it is, 0.417, and my t is still the same thing because it's still the same amount of data, but my standard deviation is a little bit different. Oh, I should have calculated these ahead of time. I'm going to have to pause again. Okay, so I calculated these and I got the following. So this is actually negative 1.56784, and this is up to 2.408184. Okay, couple things. One of these things is definitely not like the other. So we hit D, and I'm like, oh, I know exactly who I'm getting rid of, because what you should be thinking is they're like, hey, which of these variables is, not so good when it comes to the model? And you should have had some indicators earlier. Looking back at your coefficients, I'm hoping you notice the p-value for x2 is huge. But if you didn't bother with this and you were just calculating confidence intervals, you could notice that this confidence interval contains 0, which means there is a possibility that b2 is 0 and contributes nothing to the model. So we would say that x2 is not significant for the interval, for its slope confidence interval contains 0. So I'm just going to type that. So if you want, you can totally not watch me finish this or rush to the end of this video, because I'm going to start a new video for number 4 since it is a different problem. So x2 is not significant as the interval for its slope coefficient contains 0. Okay? And that's it for this first video. So I went through 1 through 3. I will do 4, 5, and 6 next in the second part of this video.